So yan, number 4 na tayo. Yung an Otto cycle with a 7 to 1 compression ratio has a 320 BTU per pound of heat supply. At the beginning of compression process, the pressure at temperature are 14.7 psia and 60 degree Fahrenheit, assuming constant specific heat calculated. So, kung i-analyze natin ang problem, sabi niya dito, an Otto cycle with a 7 to 1 compression ratio. Bali, binigay niya yung RK. Kung iaano natin, di ba, alam naman natin kapag sinabi nating ratio is a division, di ba? Kaya, kung iaan natin 7 is to 1, bali 7 divided by 1 is equal to 7. Therefore, yung compression ratio natin is equal to 7. Then, sabi niya rin dito na meron tayong 320 BTU of heat supply. Kapag heat supply, yun yung, di ba, papasok. That's why meron tayong heat added na QA is equal to 320 BTU per pound. At the beginning of compression process, sabi niya, di ba, beginning of a compression. Bali yung position ng piston, kumbaga example natin, yung position ng piston natin nasa bottom dead center pa siya. Bali kung paakyat pa lang siya, yun yung tinatawag natin na beginning of compression. That's why yung process natin nasa process 1 pa lang tayo. Beginning of compression. Bali meron tayong pressure and temperature na pressure 1 and temperature 1 na pressure 1 natin is 14.7 psia and yung temperature natin is 60 degree Fahrenheit. Assuming na specific heat calculated. Bali pinapahanap niya yung peak temperature, yung peak pressure, yung network, yung thermal efficiency. Kapag sinabing peak temperature, yun yung parang masasabi rin natin na largest or yung pinaka-maximum temperature. Therefore, pinapahanap niya ang temperature 1 at yung temperature 3 and yung pressure 3 natin. Then, yung network and thermal efficiency or yung E natin. So, sa solution ko, ulitin ko lang yung mga given natin na RK is 7, yung heat added o yung QA is 320 BTU per pound, yung pressure 1 natin is 14.7 psia, yung temperature is 60 degree Fahrenheit. Nag plus 60 tayo kasi para maging siyang absolute na bali equal to 520 Rankine. Then yung required yung T3, P3, work net and efficiency. Sa solution ko naman, para ma-solve natin yung temperature 3, ginamit kong process is process 2 to 3. Sa process 2 to 3 is constant volume. So, isometric process. Ginamit kong formula yung heat added o yung QA na MCV T3 minus T2. Bali yung M at saka CV at saka temperature 2 ay hindi given. So, hahanapin muna natin. Bali, unang hahanapin muna natin ay yung temperature 2. Sa temperature 2 naman, ginamit kong process is process 1 to 2, which is isometric or rather isentropic process na entropy is constant. Ginamit ko yung formula ng T2BV2 kick na formula. Then, T2 all over T1 is equals to V1 all over V2 raised to K minus 1. Bali, yung V1 all over V2 is equal lang siya sa RK. Kaya, naging RK yung value dito. Kaya, naging T2 is equals to T1 quantity RK raised to K minus 1. Then, yung T2 is equals to 520 Rankine na temperature 1. Then, yung value ng RK natin is 7. Then, raised to 1.4 minus 1. Kasi dun sa problem, kaya naging 1.4 kasi hindi naman nabanggit yung K. Kaya nag-assume tayo na 1.4 yun. Then, yung value ng temperature T yung temperature 2 natin is 1,132.511 Rankine. Then, nakuha na natin yung temperature 2. Meron na tayo. Hanapin naman natin ay yung CV. Meron tayong formula sa CV na R raised to K minus 1. So, i-substitute lang natin yung mga value na yung RK na, yung R natin or yung air constant na 53.35 feet multiply pound all over pound Rankine. Then, all over yung K natin na 1.4, then minus 1. Therefore, yung CV natin is equal to 133.375 feet pound all over pound Rankine. Then, meron na tayong, nakuha na rin natin yung CV natin. So, yung mass natin, inanalyze ko siya, hindi siya solvable. That's why, nag-assume ako na 1 yung mass natin. Then, yun, makukuha na natin yung temperature 3 natin. Bali, yun nga, ginamit kong formula, yung QA is equals to MCB T3 minus T2. Bali, i-manipulate lang natin yung formula para makuha natin yung final equation natin na T3 is equals to QA all over MCV plus T2. Paano nakuha to? Nakuha to dito. Bali, yung MCV, dinistribute ko siya sa T3 and T2. Kaya magiging siyang QA is equals to MCV T3 minus MCB T2. Then, dinivide ko yung tatlo, both side ng MCV. Then, cancel. Kaya yun, nakuha ko yung temperature 3 na QA all over MCV plus T2. Therefore, yung T3 natin, i-substitute lang natin yung mga given value na yung QA natin na 320 BTU BTU per pound all over yung M natin na inassume ko na 1, then yung CV natin na 133.375 feet pound all over pound Rankine. Then dito cancel yung pound, cancel. Then meron tayong BTU per all over pound Rankine. Kaso, 'di ba sa temperature 3, 'di ba Rankine yung unit natin. So unit analysis tayo. Bali yung BTU ginawa ko siyang feet per pound. Kaya nagmultiply ako ng 1 BTU is equals to 778 feet per pound. Then cancel yung BTU natin, cancel. Then meron tayong feet per pound, cancel din. Yan. Tapos may plus pala tayo. Yung T2 pala natin dito is 1,132.511 Rankine. Therefore, yung temperature 3 natin is equal to 2,999.128 Rankine. Bali, nakuha na natin tong temperature 3. Then, sa pressure 3 naman tayo. Sa pressure 3 naman, yung ginamit kong process is process 2 to 3 or isometric process. Ginamit ko yung P2 V2 all over T2 is equals to P3 V3 all over T3. Bali, i-divide ko lang siya, or di ba alam naman natin na yung isometric is constant volume, so maka-cancel lang yan. Yung natin, initial formula is P2 all over T2 is equals to P3 all over T3. Then cross multiply, makukuha natin yung final formula na P3 is equals to P2 T3 all over T3. Dito naman yung P2 naman hindi given. Ito given naman, nakuha na natin pati ito. Then hanapin natin yung P2. So find P2. Yung ginamit ko naman dito yung relationship ng P1 at pressure volume na P1 V1 all over K is equals to P2 V2 raised to K. Then, para makuha natin yung final formula, nag-divide lang ako both side ng V2 raised to K, kaya cancel. Therefore, yung P2 natin is equals to P1 RK raised to K. Sinabi ko namang sa previous ko na previous problem na kapag V1 all over V2 is equals to RK. Therefore, naging RK ito. Then, P2 is equals to, meron tayong P1 na 14.7 PSIA, yung RK natin na 7, then naka-raise siya sa 1.4. Therefore, yung pressure 2 natin is equals to 224.107 PSIA. Yun, nakuha na natin yung pressure 2. That's why pwede nating ma-solve yung pressure 3. Sa pressure 3 naman, yun nga, no, i-substitute lang natin yung mga given value na yung P2 natin is equal to 224.107 PSIA. Then yung temperature 3 natin na 2,999.128, i-divide natin sa 1,132.511 Rankine. Therefore, yung pressure 3 natin is 593.483 PSIA. Yun, nakuha natin rin yung pressure 3. Hanapin naman natin yung E, no? Hanapin natin yung efficiency. Sa efficiency, meron tayong formula na E is equals to 1 minus 1 all over RK raised to K minus 1. Substitute lang natin yung given value na 7 na RK, bali makukuha natin na final value ng E is equals to 0.54084 or 54.0084%. Yan. Kunin natin yung work net. Bali nakuha natin tong efficiency, then hanapin natin tong work net. Sa work net naman, yung ginamit kong formula is E is equals to work net all over QA. Kasi kung kukunin natin yun sa pinaka-formula ng work net na QA minus QR, bali hahanapin pa natin yung QR, di ba? So parang mas mahaba yung process kung kukunin pa natin yung QR. So naisip ko na gamitin na lang yung efficiency para mas madali. Since given na nga yung efficiency and yung heat added, bali makukuha na natin yung work net para mas madali, di ba? I-cross multiply lang natin yung final formula natin. Work net is equals to efficiency multiplied by heat added. Bali isa-substitute natin yung E natin, nakuha natin na 0.54084. Then i-multiply natin siya sa given value na QA na 320 BTU per pound. Therefore, yung work net natin is equals to 173.069 BTU per pound. Yan, no? Bali nakuha na natin yung work net. Bali yun, tapos na natin. Nakuha na natin lahat yung mga required na nung problem. So, yun lang.